because this is not saying the y intercept is negative 1. This is an equation. An equation having a y intercept. So your slope.
Alright guys, I see a bunch of y'all are about done, or y'all done what you feel like you can do. And so, since we want to save as much time as possible, we're going to go ahead and start, okay? So, I'm glad y'all are back from break. I feel like I haven't seen y'all in forever because we've had so many B days, right? And so we finally got an A day, and so we're finally here together, all right? So, today we're going to start a new unit, okay, and we're going to start talking about quadratics. Before we were talking about linear equations, so it was just straight lines. Now we're going to talk about quadratics, and we'll get into that later on, okay? But in order to do today's lesson, we need to make sure that we know how to do this do now, okay? So whenever we had y equals -1, someone come up here and show me what that looked like. Take yours. Jocelyn, never get to hear from you. Come on. Hurry. Okay, did anybody have anything different? Okay, Kedra, come on up. Okay, and with lines, guys, what do we do with the lines at the ends? So this is how we draw a line? Arrows. Make sure you have arrows on your line. Now, Jocelyn, what is the difference between here and here? What do you think? Why do you think she put it above 1? Because it's a -1 and you put it at -2. Right. Okay? So then this one I'm going to go up how many, guys? 6. So 1, 2, 3, 4, 5, 6. And then for this one, 1/2 is between what and what?
0 and 1.
0 and 1, so I'm going to go halfway. Draw my line like that. Now, let's think about this. Why do y'all think it's, what kind of lines are they, first of all? Horizontal. Why do you think whenever we have y equals something, why do you think it's a horizontal line? Why is it a horizontal line? Talk to your groups. Think about why. Why?
Then it has to cross the y intercept. So it's just like that. It's the total.
What is that?
I'm not married. Yes.
How old is your part?
Okay. Alright. Who thinks they have a good idea of why y equals -1? Okay, it's the same hands. Did we not talk? Okay, Alexis, what do you think?
Horizontal. Wait.
why do you think this equation, anything with y equals a number, is a horizontal line?
Because like, this, oh, no, I don't know how to answer.
Yes. Antonio?
Because it doesn't have a slope.
Doesn't have a slope? Okay, that's one thing. Our equation is y equals mx plus b, right? What is this negative 1? What letter? The m, the x, the b, the y? What does that negative 1 represent?
The y. The y.
This negative 1 is here?
And
So we put negative 1
Oh, okay, I get it now.
equals mx plus b?
Yes.
That's where we put that negative 1?
Oh,
That's what that looks like?
no.
No.
It's M for slope.
This negative 1 is a slope?
No.
It's B.
Guys, what is the slope always next to?
The X.
Do we have an x here?
No.
No. So can this be the slope?
No.
No. I think all these breaks have gotten into your heads, guys. Alright, this is what letter? B. Which B is the what?
The y.
The y-intercept. We have a y-intercept of what?
Negative 1.
Negative 1. Now, if I were to ask you what the ordered pair is for this point right here, I go over how many?
2.
2, and then the y value would be what?
1.
Negative 1.
Negative 1.
If I tell you to give me this ordered pair,
Negative.
-2,
Negative 1.
and if I tell you to give me this ordered pair right here, okay? This is 1, 2, 3, -4, and what's the y value? What is happening to all of our points? A -1 for what?
The y-intercept.
The y-intercept, yes, but what about these? Guys, y-intercept is not the same thing as points. A point is made up of what and what?
X and y.
X and y. What are all these y values?
Negative 1.
-1. So that is why the y is always equal to
Negative 1.
-1, okay? Here, if I have an ordered pair, what's the ordered pair of this point right here? How many do I go over?
2,
1.
1, and then I go up how many?
6.
If I have a point right here, I go over 1, 2, 3, 4, 5.
5.
So that's 5 and
6.
6. If I have this one right here, that's going over 1, 2, 3, 4, 5. 5 and
Negative.
Isn't it negative?
oh, -5 and
6.
+6. We went up 6. Okay? So whenever I have ordered pairs, my y value is always going to be what?
The 6.
The 6. Okay? So all these points, all their y values are always going to be what? Because I'm always up at 6. Right? So here, the same thing. What is the y value for all these ordered pairs going to be? 1/2. Okay? Does that make sense? All right. So what is the slope for all of these then? What's the slope, guys? Did we have an x here?
No.
What times x is going to give me 0?
1. Oh, 0.
0. So this is 0 right here. So my slope is equal to 0. If you do rise over run, okay? Now this is a long time ago that we talked about this. If I go from here to here, how many am I rising? From here to here, how many am I going up or down?
None.
None. So what number is that?
0.
0. From here to here, how many am I going to go over? 1, 2, 3, 4. Then what is 0 divided by 4? 0. Okay? If I go from here to here, tell me what the slope
You
is.
rise 0 and you run 1.
Rodriguez class.
So, you run 1.
Yes.
But it'll still be 0.
To go home? Alright. Let's all go so far like this. Alright, so from here to here, how many did I rise? How many did I rise, guys?
0.
0, and I went over
1.
1. And 0 divided by 1 is?
0.
0. So what is the slope?
0.
0. Okay? Alright, so now we're going to go on to the bottom part. How many of y'all think y'all graphed the next part correctly? These right here. How many of y'all think y'all can do it now? If Y'all use y'all sense now. So use the logical sense, the logical reasoning of how the y value was always that number, and so that's why we got a horizontal line. What kind of lines are we gonna get now? What? Are you sure? Draw 'em, draw 'em, draw 'em.
I think, were you gonna draw the dot along the x-axis?
Yeah, I already tried.
Why can't you draw this? Why? It's a number. That's a number, and you drew it. What's a number? What number is it? Are you sure? If you can't understand fractions, put it in a decimal. How do you know this is a decimal? Exactly.
So,
So draw that.
what?
Try to.
No, you gotta make it into fraction, I mean decimal.
Where are all your x's going to be?
And then when you count it and try to make a point.
Alright guys, let's look up here. Okay? Majority of y'all got it. Okay? Majority of y'all got it. Some of y'all are still struggling. What is this sign right here? Let's all look at this sign. What is this sign?
I mean, equals.
Equal. What does equal mean, guys? What does it equal mean?
To be the same sum.
To what?
What's the sum of
Same.
Some? I thought that was a plus sign. Equal means same, right? X. Where do we have x's, guys?
The
on the
first
left.
number.
Okay? So we're saying that all the ordered pairs, anytime we have an ordered pair, the x is always going to be what? X is always going to be what? X is always going to be what?
3.
X is equal to 3. We know that, guys, whenever we do this, x equals 3, and we have an equation. What do we do with this x here?
You plug it in.
Why do we plug it in?
Because that's what it's saying it equals.
And it's the same thing, right? So we just plug in. Here, they're telling us to plug in everything that is an x for what?
3,
For 3. So what am I going to put here?
3.
3, and I'm going to have whatever y, any y in the world, okay? So when I look here, okay, how do I go to my x's? Where are my x's? Up and down?
No,
No, I go where?
the x-axis, which is
Okay, right here.
Right.
yes,
And then where am I going to go, left or right?
right,
1, 2,
3.
3. This point is what?
3.
3 what?
0.
3, 0. Where else am I going to have a 3? Where else? Can I have a 3, 1, 2, 3 here?
Yes.
Yes.
Yeah, that's x equals 3?
No.
No, what is that 3?
That's always 1.
Y is equal to 3. The value here is y equals 3. Okay, so 3, what about here? Will my x value be 3 here?
Yes.
What is the value? Okay, 1, 2, 3, and then I go down. So my ordered pair would be 3, negative 1, right? Is my x value still 3?
3.
Yes. What about here?
Yes.
I go 1, 2, 3, so my x value is
3.
3, and I go up 1, 2, 3, so my y value is 3. So what kind of line is this going to produce? If all these points, all the x's are always going to be 3.
A vertical line.
Vertical line. Okay? So if my x equals negative 2, where am I going to go? 1, 2, I'm going to go up and down. Okay? Now this one. Bunch of y'all did some crazy things. Some of y'all said that it's between 4 and 3. Okay? It is not between 4 and 3. This is a fraction, guys. If y'all see it better in decimals, go ahead and change it into a decimal. Someone give me, everybody put it in their calculator. Put 4 divided by 3 and tell me what that equals.
1, 2, 3, 3, 3, 3.
It's the same thing as negative 1.333, repeating, right? Okay? What is 1.3 between?
What is it?
1 and
2.
but it's on the negative side, and a third, it's like if you were to break this down into 3 pieces, 1 of the thirds is right here. So, make a line between, that is 0.
Yeah, that's 0.
1 and 2. And your line should have been there, okay? So, anytime you have an x equals something, what kind of lines are you going to produce?
Vertical.
Vertical. Anytime you have a y equals something, you're going to get a
Horizontal.
horizontal. Okay, write that down. Anytime you have y equals something, you get a what? Anytime you get an x equals something, you get what kind of line? Write those 2 sentences down. Y equals a number, you get what kind of line? X equals a number, you get what kind of line? Alright guys, so again, x equals a number gives you what kind of lines? X equals something gives you
Vertical line.
vertical lines. What kind of what gives you a horizontal line?
A Y.
Y equals a number, okay, a constant. Alright, now, really quick, I'm going to show you a picture of Miss Rodriguez celebrating what day?
Pi Day.
Pi Day. Did anybody know that was Pi Day this spring break? 3/14. I bought a shirt. Miss Rodriguez is super nerdy. So pi is 3.14159265 and so on, right? You know what pi is?
Yes.
Those circles, right? So if you break this into a date, 3/14/15, March 14/15, 2015. This only happens like once in a lifetime, okay, guys? That's why I said it only happens once in a lifetime, okay? And then you have 9 hours, 26 minutes, and 53 seconds. So I celebrated and I ate some pie. Okay, I went to Emporium Pies in Bishop Parks District in Dallas. There was tons and tons of people. They were handing out these little pins that says "Shut your pie hole." Okay, all right, I guess no one cares. These were the pies. They were so cute, wrapped up. And that says there's my whole shirt right there. It only happens once in a lifetime. Has the pie, and it says Ultimate Pie Day. So your teachers definitely celebrated Pie Day because it's an amazing day. But none of y'all care, so it's okay. Alright. Okay, so moving on. So today's objective, read it for me, Daisy.
Students will be able to identify the characteristics of quadratic function.
Quadratic. Everybody say quadratic.
Quadratic.
Quadratic. Okay, I told y'all we're going to talk about quadratics now. Alright, today we're going to be thinkers and communicators. I really want you to think through what you've learned on your Do Now and try to apply it to this next lesson, okay? And then statement of inquiry. Okay, so this is the overall, overarching thing that we're going to do with quadratics. So quadratics, we're going to see, quadratics look something like this, guys. Looks like a U-shaped graph, okay? That's what a quadratic is. We're going to use quadratics to make decisions, and you're going to see that everywhere in our life, there's quadratics being formed, okay? And they can be used to make decisions to improve certain technologies that we have, or someone raise your hand, think of, or just take like 10 seconds, think of something that has the shape that you use every single day on your way to the restroom in Mighty. What do you think? So the toilet goes like this.
Oh wait, you said U shape. Oh, never mind.
Think of something you pass by the restroom, especially when you're thirsty. Oh, what?
The water fountain?
Water fountain, guys. Yeah, think about the water fountain, right? You have a little thing and then it goes like this and it goes into the drain, right? What if they didn't calculate it correctly? What if the water went like this? Where would it fall? On the ground. People had to calculate, they had to calculate how much it was going to go over in order for it to make sure that it went into the what? The drain, right? So that's one example, okay? It's one example of how we use quadratics in our real life. Now, our agenda for today, do now, we took a little bit over 20 minutes, but it's okay. So the hook. Now, we're gonna look at a couple pictures. And I just want y'all to explore with your groups these pictures. Okay, and I want you to answer the question. So let's look at it. Do not write on it, guys. It says, look at each of these shots. For each of them, determine whether you think the shot will go in. It says feel free to write on this photograph. Don't write on it, okay? So which one of these do you think would go into the basketball court?
Use like a pin.
Look at it.
You're using yeah, confusion is all over you. This one is it even going towards the hoop? It's towards the tree.
This is pretty cool.
This one's going over.
Yeah, so this one.
What's happening here, guys?
Shooting a basketball.
Shooting a basketball, okay? Now, I have a basketball here, guys. Let's look at my basketball. You guys see my basketball? Okay? Now, if I'm trying to hit Mr. Jackson, he's the hoop, okay? I'm trying to hit Mr. Jackson, alright? If I just go straight up, is that going to get him? Get to him? No? Okay, what do you think I need to do?
You need to arch it a little bit.
Arch it a little bit more? Okay, if I arch it a little bit more, it gets there, right? Okay, now, how do I know that I need to arch it? How do y'all know that? Like, why can't I just go straight up?
Because it'll come straight down.
Okay, it comes straight down. But what if I go straight up that way? Well, we still went straight up, right? But how do y'all know where it's gonna land? How do y'all know where this basketball is gonna land? If I were to, because it's a what? It's like a U shape. Could I kind of predict and draw this?
Yeah.
So it would be kind of like this?
No, it wouldn't just fall in the woods.
Why not? Dead? So it's just gonna go like this?
No,
Why?
Keep going.
Why? It's gonna go like this?
because no.
If it hits, it hits.
Someone show me how it's gonna look. Okay. Y'all agree with me? Yes, some
Yes.
yes. Daisy, you don't agree?
I feel like it's gonna go like.
How do you
Going
know?
to the trees. Right.
But how do y'all know? Like, why did she put it like right here? How did y'all not know it's right here or over here or like something like this?
Cause it looks like it's going in the
Okay, and what do we know about U shapes? If they're drawn correctly, if I have a perfect U, what do I know about this perfect U? Think, guys, look at the vocabulary words. What can you use from here? Think, what word here makes sense that we're trying to think about? Talk with your groups. What word? Hearing it from one group. What do we think, guys? So what is that word? It's symmetrical. Do y'all see this word right here? Yes? Does anybody remember? Raise your hand if you remember the word symmetry from your past math. What does symmetry mean? What does being symmetrical mean? What does it mean?
It means to be like the same, to look the same on both sides, and there's a line between it.
Okay, so if there's a line between it. So if I go like that,
No,
It's not
straight in the
symmetrical.
middle.
A vertical line.
that is in the middle.
But that's not
Or
symmetrical.
vertical.
A vertical line, right? Didn't we just deal with vertical lines, guys?
Yes.
What would be the, if I had this on the x-axis like this, and this is at 1, 2, 3, what would the line be of this line of symmetry, right? Can we call it the line of symmetry?
Yes.
Yes? What would this equation of this line of symmetry be called? What would the equation be? If this is at 3.
Y equals 3?
So y equals 3. That's what we did on our do now? Y or x? Which one?
Oh, x equals 3.
X equals 3 because it's a what kind of line, guys?
Vertical.
Vertical line. Vertical lines, the equations start with what letter?
X.
X. So what are we going to call this line right here?
Line of
Line of
symmetry.
symmetry.
Line of symmetry. Now, what kind of vocabulary word on this wall right here do we have that kind of sounds like
Axis of symmetry.
axis of symmetry? Axis of symmetry. Okay, that's what we're going to call that line. All right. So this axis of symmetry, since we are all of our parabolas, guys, and the word parabola. Everybody say parabola.
Parabola.
Parabola. You see it right here?
Yes.
This is what we call a U shape. So instead of calling it U shape, we're going to call it what?
Parabola.
Parabola. Okay? Now, our parabolas are U-shaped, right? One thing that we know is that they have a what kind of line? Axis of symmetry. What is the equation always going to be then? If it's always up and down.
X equals.
X equals
Something.
some number, right? So do we know how to write an axis of symmetry? Yes? Okay. Now, do y'all see any other words here that y'all could possibly kind of talk about to kind of define any part of this graph right here? Look at your vocabulary words. What kind of words here do we have that we might be able to call any part of this graph here? Vertex, what do you think the vertex would be? Where would you say the vertex is?
Well,
If I had this is my graph right here, right?
yes.
Where would be my vertex? Where would my vertex be?
The vertex will usually be like a point at the end.
Okay, so you're saying like right here?
Yeah.
Okay, y'all agree, disagree? What do y'all think? Where do y'all think the vertex would be?
I want to say the highest point reached.
So right here? So she says the vertex. Raise your hand if you agree with, if you want to agree with Dominic. I mean Damien, sorry, Damien. No? Let's use our hands. I don't know, like agree or disagree. Everyone, let me see. Okay? Raise your hand if you want to agree with Stephanie. Show your hands, do your hand signals. Okay? Yes, Stephanie is actually correct, guys. Okay, Damien, he actually noticed another part that is very, very, very important, but we're going to call this something else. So everyone, we're going to call this what?
Vertex.
Vertex. Okay? All right? Now, we have another one. Now, she also used some other vocabulary here. What did she say? Someone else besides Stephanie. What did she call this vertex? What else did she call it? Tell your partners, what else did she call it?
What did I tell you?
What words here? What can we use right here?
I do. I'm asking.
Let me see.
What words? What words? Ashley, what words? What words? Mm-hmm. What other words can we call this? She said this is the highest point, right? What words can we use here? And minimum. How do you think we could get, because this is what would this be, a maximum or a min?
The maximum height.
Max, because the highest, right? How can we make this a a minimum. What do you think it would do to make it a minimum? To make this point the lowest point. The other way. So if we go like this, now what do we have? We have a minimum. But this is still called a
Vertex.
vertex, okay? Right? So we use these two words here. Right?
Yeah.
Alright. Now we have, so we use this word as well. Okay? Roots. Solutions, x-intercepts, zeros. Okay, I'm going to draw y'all a graph. Here's the x-axis, here's the y-axis, here's a parabola. Okay? What is this point called here?
Minimum.
A
Vertex.
minimum, and it is the vertex. Right? Now, what if, so here, is this ever going to finish going up? No, because they have what at the end? Arrows, okay? So it's not gonna end here, okay? Damien was kind of on the right track, right? What else do you think we can use here, given this graph? We're almost done with all these different vocabulary words.
Roots.
Roots. Where do you think the roots would be? Okay, he says at the end. That's a good guess. What other words do we have? These are all the same. Me.
Solutions,
Solution. Can we, do you think we know what this is? Can we guess at what an x-intercept is? Talk to your groups. What would be an x-intercept?
I think where it's like.
What's an x-intercept?
Intersecting with the x-axis.
What would an x-intercept be?
Those two points.
What's a
You
minor?
agree?
Yes.
What is it? No.
Think about what a minor is. I'm coming back to you. You're going to tell us.
Meron po na ito.
Okay, did we talk over here?
What do you think the
What
zero
is- why- what is it?
I mean,
Y'all know what it is? No, no. Do y'all know what a y-intercept is? Talk about what a y-intercept is.
It's basically the X line.
Did everyone get a quadratics paper?
yes.
Alright, so let's look at this, okay? We have an x-axis here, and we have the y-axis. So here on my y-axis, what do you think this point is going to be called if this is the y-axis, guys? Y-intercept, okay? Now this is my what axis?
X-axis.
X-axis, okay? What do you think we have then?
X-intercept.
Where would the x-intercepts be?
On the
Those
X
two
line.
there.
Is this an x-intercept here?
Yes. No.
Here?
No.
Here?
Yes.
Is there anything else that intercepts the x-axis?
And the other side.
The other side as well. These are called your,
X-intercept.
okay? So how many x-intercepts do we have here?
Two.
2. Do you think we can have more or less?
Not with the
Parabola?
parabola.
Okay? Okay, let's just go ahead and go to our notes then. See what we can do now from our notes. Let me pull these up.
Ooh, 3 power X is 2.
Oh my gosh. Yes. Okay. Screw attendance. Alright. Give me a second, guys. Go ahead. While I take attendance, I want you to discuss with your partners what a parabola is, what an axis symmetry is, what a vertex is, maximum, and what symmetry is. Okay, talk to partners. Keidra, get in
The
there.
parabola is the
The line
You already know. Or after that.
on the peripheral is the first
And then you should.
the y-intercept is the little u. What is
Actually,
Well, it's just
Vertex.
the fullest, the highest.
Keep going, because y'all are gonna be tested over.
Minimum,
this.
I
Keep-
think it
keep
means-
telling you. Quiz each other. What is the parabola?
Like-
What is the active symmetry?
It can go, like, it can't go no more. So it can't go no more.
No more on the bottom, or no more lower? No
Lower. And symmetry,